Climate change is a global problem so complex, there is no singular approach for solutions. IFAS scientists are working proactively to address the impacts on Florida's animal production, human systems, natural resources, and agricultural crops. At IFAS Research, we will adapt and thrive despite these inevitable changes.
My research is focusing on addressing issues of economic importance for Florida producers. Heat stress in particular, it's probably the major limiting factor for production efficiency, and that is more important in tropical and subtropical regions. If you look at beef cattle, about 50% of the cattle in the world are in tropical and subtropical regions. We're trying to discover the genetic variants which are responsible for thermotolerance. This is not an easy trait to measure on a regular basis, and so genomic selection is really the most efficient way to try to improve our populations which are at risk of exposure to high heat stress. The phenotypic measures that we take in the field are going to combine with genomic research, so we are able to look at 250,000 genetic markers in one animal at one time. If you look at the perspective of global climate change, the effect of the high heat stress situation is only going to intensify as we go forward. If we have genomic tools that producers can use, then we can try to select our populations so they are more resistant to heat stress.
My research focuses on environmental economics and policy. In this particular research, when we're looking at climate change, we focus on the sea level rise problems, because Florida has one of the longest coastlines, and most of our population are located along the coastline. First, we want to figure out whether the residents, what are the knowledge about sea level rise? Do they have experience about it? Do they believe there is threat from sea level rise? And then what are the adaptations that they have observed? And what are their preference on those adaptations? I think all the adaptation strategies, they have positive willingness to pay for such adaptations. They prefer beach restoration or nourishment, building seawall, but they are less familiar with using pumping stations to pump the water back to the ocean. They're least likely to choose the elevating the roads. The long-term goal would be to have a group of researchers or scientists focus on this aspect, because it is very important in Florida, and we can be one of the leading organizations that looking at the social economic dynamics of how nature and human systems interact.
Oyster reefs have declined pretty much throughout their range in the United States for a variety of different reasons. Here in the Nature Coast, we have narrowed it down mostly to declines in freshwater. In this project, what we're trying to do is use oyster reefs to make the most out of the freshwater that we do have. Oyster reefs serve a really important function here in the Nature Coast, where they form what are essentially offshore barrier islands. And those barrier islands occur in chains that are parallel to the coast. They occur in places where springs and rivers discharge fresh water into the Gulf, and they tend to dam that water up. It's a leaky dam, and so they end up creating intermediate salinities behind them. And that's exactly what oysters like, so those tend to be better places for oysters. Those are also better places for a lot of the fish and other shellfish that we eat. So those estuaries are where 90% of American seafood spends some portion of its life. We've done a pilot project that demonstrates that we can use lime rock and oyster or clamshell to rebuild the reef. And we've demonstrated that we can increase oysters by about a factor of about 9 by doing that. We're also providing a very permanent sort of a substrate in the form of large rocks. Even if the reef dies off, it can come back to those rocks because they're relatively permanent. Now the question is building the entire chain. Oyster reefs are very susceptible to climate change because they're living in this nearshore and very shallow water zone that is likely to be strongly impacted by climate change. Essentially, by restoring a thin ribbon of oyster reef, you're actually magnifying that effect and restoring an entire estuary.
We use computer models which calculate how plants or crops grow in the field. And we use these models to try to understand what climate change will do to crops. And we also get to understand the impacts of what we can do about it. Can we actually take advantage of certain changes? Or do we need to change things we do to adapt to some of these changes? We have a new project funded by USDA and IFA where we've been asked to look at specialty crops, particularly into 3 areas, which is California, the Pacific Northwest, and the Southeast with Florida. Over the 4 years of the project, we tried to get through 8 different crops. We started with potatoes. We tried to use our simulation models to first see, can we reproduce what's happening right now there under the current climate conditions? And then in the next step, we started looking at what's happened if we overlay climate change as we think it will happen in the next 30, 40 years, with higher CO2, with warmer temperatures, and changes in rainfall and so on. We try to understand what's happened with the crop on the ground. Then we take this information and pass them on to economic modelers. They put it into a farm economic modeling. But then we take it the next step of how do we get these crops to the market, how we process this, how we store the food. So we're looking at life cycle assessments. Climate change is impacting agriculture right now. And as scientists, we want to try to help finding science-based solutions for the society to make the right decisions for now and for the future generations as well.